Hey folks, this time around we need to take a look at diffusion and osmosis. This is going to be kind of a rough draft, but I needed to get it out to you so we could make use of it this week. Diffusion, as we already know, is taking any molecule and spreading it out or letting it spread out under its own power. All those little molecules are wiggling around, and that eventually gets them to spread out and be everywhere in the same concentration. Molecules move from areas of higher concentration to areas of low concentration. This is the way perfume works. Smoke detectors work this way. Pumpkin spice lattes, for some reason, work this way. Ew. And, anything else that has a scent to it works by diffusion. In this case, we have lots of chickens, lots of hens, and they are not happy with me because they are not allowed to go outside yet. And there's a high concentration of hens. The door on this chicken coop is going to serve as my cell membrane because it can control what goes in and out. And as soon as I open that door, then the chickens, in fact, can go from an area of high concentrations of chickens to an area of low concentration of chickens. And every now and then they come sliding out and straw comes flying out also. Now, semipermeable simply means something that allows some materials to come through and keeps other materials out. In the case of a bug net, it lets the air blow through and keeps the mosquitoes and the little bitey crawly things off of you. If you've ever used a window screen, if you've ever cleaned a litter box, ever made pasta, you probably used something that was semi-permeable. You're going to run into occasionally something that says selectively permeable. It is, for our purposes, the same thing. A cell membrane. All cells have a cell membrane, modeled by my chicken coop door. You've actually seen a cell membrane. If you've ever peeled a hard-boiled egg, hey, next time you see the hens, say thank you. Underneath the tough shell, there is a thin membrane, the part that you usually pull off before you eat. That is the cell membrane of an egg. Remember, an egg is probably the biggest cell you're ever going to see. And they're pretty darn tasty. Osmosis is the diffusion of water through a semi-permeable membrane. Here, the poor gummy bear has a low concentration of water inside and a high concentration of water outside. And over time, the water is going to go from high concentration to low concentration. And eventually, the gummy bear gets to be very, very big. No real bears were hurt in the filming of this video. Solvents and solutes and solutions. You're familiar with solvents and solutes because you've probably made Kool-Aid or hot chocolate. The chocolate here serves as the solute. That's the thing that gets dissolved. And if my son asks, I only put 1 scoop in, he will get on my case if I use 2 scoops. In this case, the solvent is water. Water is often referred to as the universal solvent because lots of things dissolve in water. Together, a solute and a solvent make a solution. Solution wasn't one of the words we need to know this week, but you're going to run into it often enough that I thought we should at least put it out there. Other solvents you might use, WD-40 is one of my favorite solvents. It takes lots of stuff off. I have some stuff in the classroom that will take any marker off the desktops. Fingernail polish is a solvent, and there's even paint remover when you make a mistake when you're painting a house. In this case, the very nice man is sitting in an imaginary cell. Yeah, he doesn't have cable. There's more salt inside the cell than outside the cell. In this case, then, the inside of the cell would be hypertonic. Outside of the cell would be hypotonic. We need to remember that these words, hypertonic and hypotonic, are comparisons. You can't just have a solution that is hypertonic. It has to be hypertonic to something. It's like saying something is hotter. Well, unless you know hotter to what, you wouldn't know what you're talking about. Now in this setup, we've got more solute, the salt, outside of the cell than inside. The inside of the cell is hypotonic. Remember, hypo rhymes with low. There's a low amount of salt there. The outside of the cell is hypertonic. There's a high amount of salt there. In these cases, the water's always going to flow from hypo to hyper. Finally, if there's exactly the same amount of salt or solute inside of a cell as outside of the cell, we call that isotonic. There's no flow in or out because everything is even, everything is smooth, everybody's happy. It's a low pressure sort of thing. It's the way you want to live your life. You want to be just smooth and easy, which is the reason why I think all the cool kids say, keep it isotonic. And as you can see, my video helpers, they're all convinced me that, yeah, maybe you don't say that, but I think you should. So keep it isotonic. Finally, it's not finally, there'll be one more finally after this. Cells are tiny. What's up with that? Cells are tiny because we need to get materials in and out mostly by diffusion. In my pretend cell model here, you can see my pretend oxygen molecules are finding their way all the way inside the cell. They can go from outside to inside, no problem. On the other hand, if a cell were the size of the gym, then oxygen molecules would never diffuse all the way to the middle of the gym, waste would never diffuse out, and the cell would die. So, moral of the story, lots of little cells, really good. Lots of big cells, not so good. Turns out that an amoeba can never grow to be the size of New York City. So you don't have to worry about that. Cross that one off your list. If all you're going to do is to look at this and then never think about it again, I've wasted your time and you've kind of wasted mine. So do something with it, review your notes. You can't learn osmosis by osmosis. Also, every now and then it's good to turn the computer off and go out and play in the woods. So that's all for now. Keep it isotonic.